Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Alila and today I'm going to present about the design of radiation therapy problem. So in this case, we have that Mary has been diagnosed having cancer, and we need the equation to determine uh, within two beams uh, how can we make the combination that the beam is going to be used and the intensity of each one to generate the best possible dose distribution. So here is the data that we have for Mary's radiation therapy. Here we have beam 1 and beam 2. And here, from the data that we have, we can make the linear distribution from the data. We have the minimized z is 0.1 x1 plus 0.5 x2. Why we have that for the z? Because that's the half anatomy, and that will be the one that will minimize. And for the other constraint, we have the beam 1 as x1 and beam 2 as x2 here. For the critical tissue tumor region and center of tumor, we put it like this. And because the first constraint is less than that, we add plus x3. But because the last constraint is bigger than, we put it minus x4 here. And because the second constraint is already sama dengan, so we don't have to change that. Next, because the second and the third constraint doesn't have the basic variable yet because it's still minus, we added x5 and x6, but there we added big M. So the Z calculation was added from only 0.4x1 plus 0.5x2. We added the basic variable x3, x4, mx5, and mx6. There we can put all of the numbers into the iteration table sesuai dari x1 masuk x1, x2, dan seterusnya. Here we choose the column 4 and the row 3. That's because when we search for the 0 in x1 and the others, the 0 of x1 is the most minus atau minus paling besar. That's why we use the first column. And why we use the third baris is because the what is it called? The when you divided the constraint and the x1, like 7 bagi 0,7, 6 bagi 0,5, and 6 bagi 0,6. The most least number is when you divide 6 divided by 0.6. Here we have for the first constant is 23 when you divide it. The second one is 12. And the last one is 10. That's why you choose the third baris. Next, when we have the row and the column that we want to use, the titik tengahnya must be 1 and the other baris has to be 0. So we so that this 0.6 can be 1, we have to divide it by with 0.6 also, so we get 1. So in all of these third baris will be divided by 0.6, and here's what we get. And to determine the second iteration, the second plus sign is also with the biggest minus on the baris C in the row C. Here in the row C, our biggest minus is in the x4, that's why we choose the x4 column. Then, with the same method, we have to find the ratio, and that's how you find the ratio. It's by dividing the constant here and the number in this column. So like 4 divided by half, 1 divided by 0.83, and the smallest ratio is the second line, so that's why we choose the second line to be highlighted. Back again, and for the middle part, it has to be 1. So we will find the OBE to make the second line in the x4th column 1. And here we get in the third iteration table, the 0 is already all plus. So we have the conclusion for the x1 is 12. Here we can see in the constant, x2 0, and the z is 4.8. So for the dose from beam 1 is 12, and the dose for the beam 2, there's none or 0. And the entry dose absorbed by the health anatomy is 4.8 kilograms. That's from the Z equation. I think that's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.